Hello everyone, we are going to demonstrate Scientech 2203 frequency modulation and demodulation techniques. This instrument we have designed in TechBook format. You can see this is a TechBook format. On the outer cover, we have provided the block diagram and the waveforms of the FM modulation and demodulation techniques. And inside of the cover, we have provided the in-depth study of the frequency demodulation and modulation and demodulation techniques, block-wise explanation. And these are the blocks, various blocks used in frequency modulation and demodulation techniques. I will explain each and every block's working, and then later on we will perform the experiments. So let's start with the block diagram explanation. First block is audio oscillator, and this is test point, output test point for the audio oscillator. There are two potentiometer for frequency and amplitude. Frequency is from 300 Hz to 3.4 kHz and amplitude is 0 to 10 volt peak to peak. Both frequency and amplitude are variable. With the help of this potentiometer, you can vary the frequency and you can vary the potentiometer also. Next block is reactance modulator. Before this, I will explain you one thing, that is, we have provided switches over here to select the particular block. If you want to select the reactance modulator or any other block, you have to press this switch. So this is switch for selecting the particular modulator scheme. If you want to select reactance modulator, reactor modulator, you have to press this switch. By default, it is selected on the reactance modulator. As you can see, the light is glowing. It means reactance modulator has been selected, and the output is coming over this test point. This is the potentiometer given in the reactance modulator block. This is for varying the carrier frequency 458 kHz. Next block is, by selecting this switch, you can select the next block, that is varactor modulator. This is also carrier frequency of 458 kHz with plus minus 2 kHz accuracy. Again, there is a potentiometer given in this block to vary the carrier frequency. Next is noise input mixer amplifier block, whose work is to mix the carrier frequency and the audio oscillator to give the modulated output at this test point. You can see the modulated waveform. Next block is amplitude limiter. This block removes any unwanted amplitude modulation due to the noise interference. For selecting this block, you have to simply press this switch. And if you want to deselect this block, you have to again press this switch. Now there are 5 demodulators: quadrature, detune, Foster relay, phase lock loop, and low pass filter is the final output. So, to select the particular demodulator block, a detector selection switch is given over here. By default, it is on quadrature detector. So, modulator signal goes to this particular block, and output comes from here at this test point, and this is a path for the low pass filter, and finally you receive the demodulated waveform, that is the audio oscillator waveform, demodulated sine wave. Now, to switch on for the next demodulator, you have to simply press this switch. Now you comes on detuned resonator. This is input, and finally this is output of the detuned resonator. Again, these signals goes to the low pass filter, and you can see the demodulated waveform. Now you can see that the signal is somewhat over amplified, So you have to decrease the gain of the low pass filter, and this low pass filter has a cutoff frequency of 3.4 kHz. Again there is a next block, or you can say next demodulator, Foster-Seeley. Basically it has two demodulators, Foster-Seeley and ratio detector. So you can select by pressing this switch. So same, there is an output of this block and the final low pass filter output. The next block is phase lock loop. In phase lock loop there is a potentiometer given to control the VCO frequency. This phase lock loop has been designed by using a VCO, voltage control oscillator, and you can adjust the VCO frequency with the help of this potentiometer and set for the output. Now this is a separate FM modulator demodulator based on the XR2206 IC, and it is a frequency range of 10 kHz to 200 kHz, and this is carrier frequency of 10 kHz to 200 kHz. You can vary the frequency over here, and for again switching this particular block, again you have to press the switch modulator select, and this block has been selected. So you can see the LED is glowing, that means this block is highlighted. So at this test point you can see the output, frequency modulator output, and with the help of audio oscillator amplitude you can set the frequency output. So this is FM output according to the Bessel's function. This is the frequency demodulator output, and it is based on IC LM565. So this is the output of frequency demodulator, and this is final low pass filter. So now for receiving the demodulated output you have to tune the particular frequency to get the demodulated output. You can see we have received the demodulated waveform. So these are the blocks and experiment. Now I will show you each and every, there are few experiments. So I will show you one experiment and then we will finish this exercise. As I told you that this is an audio oscillator block whose frequency is 300 Hz to 3.4 kHz and amplitude is variable. So we have to keep frequency at the maximum and amplitude at 4 volt peak to peak at this test point. And you can select any of your choice of modulator, reactance modulator or vector modulator. I have selected reactance modulator. You can see the output. Now this is the output of mixer amplifier, and then I have selected quadrature detector demodulator. This is the output of quadrature detector demodulator, and the final output low pass filter. In the similar way you can select any other demodulator, detune, Foster-Seeley or PLL. So this is a simple process to operate this instrument, and this is an amplitude limiter circuit. As I told you, if there is a noise or interference in this frequency modulated waveform, this amplitude limiter circuit will remove that interference or noise and gives you a smooth output. For that purpose, if students want to do the experiment of amplitude limiter, he has to just give input to the noise input, low frequency of somewhat 100 Hz or 50 Hz of 2 or 3 volt peak to peak, and he can generate the frequency modulated with the noise, and he can again switch this instrument and he can remove the noise from the frequency modulation. Thank you for watching this experiment.